How many of you go to the office at least once a week? And how many of you feel different in the days that you go to the office compared to the ones when you're working purely remotely? So you feel different, right? Maybe a bit more tired, maybe a bit more energized. But it's definitely not the same. I'm Elena, and I'm here to tell you that unit tests have social lives of their own. And they also behave quite differently depending on how you craft them. They can be solitary or sociable. Now, I didn't invent these terms. J. Fields came up with them. But let's explore each one of them. First, a bit of background. Why do we write unit tests? What is the promise that unit tests make? A key promise of tests is that they should they should give us the confidence to refactor. They should support the maintainability and adaptability of code. They're meant to prevent our code from degenerating into that proverbial big ball of mud. They facilitate continuous improvement through refactoring. We all know what refactoring is, right? It's restructuring the code without actually changing functionality. So unit tests should provide a safety net for all our development, both new features and refactoring. But what is a unit test? My favorite definition comes from the book Unit Testing Principles, Practices, and Patterns from Vladimir Korikov. It brings clarity because it says that a unit test verifies a unit of software, it does so in isolation, and it does so quickly. While the third aspect is quite straightforward, the first two may warrant a bit more discussion. So what's a unit? The unit in solitary unit testing is the system under test. And it's often a method in a class. So what do we isolate? The natural answer would be that we isolate the unit under test. So if a unit is a class or a method, we want to test that this unit, in isolation from all external factors, behaves as we expected. All dependencies of that class should be replaced with test doubles in tests. And by doing so, we are making sure that failures are localized to the unit itself, rather than being influenced by external factors, external dependencies. So what does this mean? This means we will mock out any dependencies of that class away. Right? So let's say we have class A who has some dependencies on class B and class C. Class C has some dependencies of its own. How would we go about that? What would we do? Well, if the unit under test is the class, then naturally, we would create a class A test. We want to isolate everything, any external dependencies of class A, so we mock up class B and class C. Class Z is completely out of the question by this point. Okay, but what do we do about the other classes? Class B, class C, and all other dependencies. Their code is not currently tested. So what do? We mock them all. So we would create a class B test, we would create a class C test, we would create class Z, and so on and so forth. But by doing so, we end up having a one-to-one relationship between class and test class. We end up with a ratio of approximately 3-to-1 tests to code. That's a lot of tests. And that's a lot of code. An unfortunate fact of programming life is that code is not an asset. It's a liability. The larger the code base, the more exposure it has to potential bugs. Tests are code. Tests are also a liability. We have to maintain them now. And let me know whether this sounds familiar to you. You implemented a new feature. All tests are green. You're happy. The feature works as expected. Everything is fine. Then you look at the code and you realize, I think I could make this better. So you refactor everything. Now everything looks squeaky clean. Now you're really happy. So you decide to run the test suite again. And once you do that, you see a mini or major bloodbath in your test suite, depending on the scale of your refactoring. Panicked, you run the code again. You test the functionality. Yes, it does what's expected to do. Everything works as expected. So then why do the tests fail? The problem lies in how the tests were constructed, particularly those heavily mocked tests. Mocked-based tests are rigid. They specify the exact sequence of operations and interactions. They dictate that a certain method must be called twice before another method is called another time with a specific set of parameters. And any deviation from this sequence, even if it's an improvement or just an organizational change, triggers the test to fail. This scenario makes refactoring quite cumbersome. It makes it counterproductive. You find yourself spending significant time just rewriting mocks and fixing tests. But that was the whole promise of tests, right? That was the premise. That's why we were writing tests. To make code easier to change in a safely manner. And the exact opposite is happening. Tests become the barrier instead of facilitator to improvement. We end up with over-specified tests that rely heavily on mocks. And they make it difficult to modify implementation details without adjusting the tests. Then there's a second downside of heavy mocking, and that's opacity. Coming back to the refactoring scenario, you did some refactoring, everything is fine, yet some tests fail. So you dive into one. You dive into it, but you don't understand what precisely is being tested there. It's even puzzling why the test was green before. So you can't figure out the how, you can't figure out the why. You victoriously declare, this must be some obsolete test. I'll just remove it because there's no point in having flawed tests. Sometimes it even seems like nothing real is actually being tested. Just asserts on mocks that are being called. So what's the conclusion? Well, don't mock your dependencies. It's rude. Then how do we go about it? I think we need to go back to the initial premise of what's a unit. What should then trigger a new unit test? It's not creating a new class. It's not creating a new method. Adding a new class shouldn't be the trigger for writing unit tests, and that's a failure in understanding unit testing. What should trigger a new unit test is the need for writing a new feature, for implementing a new requirement. This means that the unit is the unit of behavior. It's about fulfilling a functional need, like updating user account details, like processing an order that the user just placed. This functional need is what should drive the test creation, because it reflects what the software is expected to do. In contrast, writing a test simply to check if a method sum adds up to numbers and returns a result, that's too much implementation detail. Such details, while they are important, should not dictate the testing strategy. Instead, testing should be based on higher-level objectives, on user needs. This is where your tests should be targeted at, ensuring that they are relevant and directly tied to the requirements of the software. So test the API of your software. No, I don't mean API in the sense of REST API or GraphQL or anything in that HTTP sense. What I mean by that is test the outer shell of your module, the public exports that face the consumers. Think in terms of ports and adapters. Don't focus on testing internals. These are implementation details. Now, there's even a common practice, I think, to make internals visible to test projects. Please don't do that. It's important that we avoid this to maintain the encapsulation of our module. This encapsulation is what preserves our module flexibility. There's one exception to this rule, though, and that's when we're touching legacy code. There, I would even advise you to go ahead and break encapsulation. Why? Because it's more valuable for that code to get under test than it is to preserve encapsulation. But other than that, don't break encapsulation. This is what tweaks your development speed. This is what makes you a faster developer. So how do we go from this, heavily mocked tests, to sociable unit tests? We have to understand that the system under test is not just a class. The system under test should be the exports of a module, its facade. Allow your tests to be sociable. Allow them to communicate with real dependencies. The unit of test is the unit of behavior. The unit of isolation is the test itself. We have to make sure that one test doesn't impact the result of another. Now, another word of caution, I would also advise to thoroughly think which classes and methods you mark as public. Don't start publicing everything now, just to make it testable. The whole point of a public class is that it defines the interactions with your module. And keep in mind, you cannot refactor a public method on a public class, because that's never refactoring. That's a changing contract. You don't know the impact of that. So be really thoughtful and thorough when crafting your contract. You might ask now, but aren't you breaking the testing pyramid if so? Well, no. These are not integration tests. Don't confuse unit tests with integration tests. Sociable unit tests test the logic from a specific component. Yes, that component communicates with B and C and so forth, but it's relevant what happens in A. Okay? The rest are just implementation details. Unit tests should focus on the smallest unit of behavior, which in this context are the public exports of a module. Essentially, the functionalities exposed to the users of other modules. That doesn't mean you're performing integration testing. You're ensuring that each unit remains focused and it's quick to execute. Integration tests, those are the tests who facilitate the collaboration between two such modules, that they get along just fine. And finally, end-to-end tests are responsible to make sure the whole system communicates well. So going back to the definition of a unit test. A unit test verifies a unit of software, which is a unit of behavior, not a class. It does so in isolation between other tests, and it does so quickly. The only reason why you would end up using a test double as a dependency is this third attribute, speed. So if it takes too long to execute in isolation your unit tests, because you need access to the database, because you need access to the file system, by all means, replace that. Replacing slow dependencies with faster alternatives, like fakes, is a strategy to maintain the test suite speed, its efficiency. And there's nothing worse than disrupting the flow of a developer. But then again, please use mocks cautiously. Use them really selectively and really think about it. So, these are the social lives of unit tests. They can be solitary or sociable. Solitary means that they are class-oriented. That means the system under test is the class or the method. The unit under test is the class or the method. The unit of isolation is the class itself. So we are isolating the unit under test by heavily mocking. This means that solitary unit tests dictate the system's design. They obstruct refactoring instead of enhancing it. They cry wolf whenever implementation details change. They're not really reliable. And they are difficult to navigate. In contrast, sociable unit tests test units of behavior. They don't dictate the implementation details. They leave that freely for you to change. The unit of isolation, it's the test itself. So we're making sure we're not impacting the result of other unit tests by running one. They enable easy refactoring. They are trustworthy. They're not the boy who cried wolf. They're not easy to ignore. Now, I don't have more time to dive into more technical details on the topic. I would love to, but the time is up. But I do post regularly on my newsletter, thesunshinelayer.com. And in next week's edition, I will dive into more details on this topic. So if you're interested, do check it out. Also, if you want to discuss